Episode 11, and the last of the Verify segment. Episode 10 ended on a placement argument rather than a mechanism. If there is nothing to detect at right time, no right time inspector can have high recall. This episode builds the defenses, and it has one advantage over most of what we have covered: the defense literature here is measured. There are numbers for how well these things work and what they cost, which is more than the attack side gave us and considerably more than the self-evolution side gave us. So this is the episode where I get to be concrete. Every claim in this episode either carries a measurement or carries a strip saying that it does not. Start where episode 10 left off. Somebody builds a store that inspects every single right. Every inspection is correct, and I mean correct, not merely passing, because there was nothing in the entry to find. 40 sessions later the entry is retrieved in a context that makes it consequential, and the consequence executes. The inspector is still passing and still right. Episode 10 put it in 5 words: the inspector was in the wrong place, not wrong. So this episode is about the other places, and there are 4 of them. There are 4 other places to put a check, and the grid near the end says what belongs at each one. 3 objectives. Place detection at both write time and read time and say what each placement can and cannot catch. The second half of that is the part people skip. Make provenance, quarantine and rollback first-class features rather than logging afterthoughts, which is a data model claim rather than a tooling claim. And assemble one integrated defense line combining Episode 9's verification ladder with Episode 10's threat model, which is the deliverable and it fits on one slide near the end. There is also a data model argument running through the middle third, and it is the part that costs engineering time rather than compute. And one boundary: this is the last episode of the Verify segment, so the governance questions that follow from all of it belong to the next 2. Here are the 2 placements on one pipeline. The write time check sees the content and nothing else: no query, no retrieval context, no consequence. The read time check sees the same content inside the context that is about to consume it, which is strictly more information about this particular use and strictly less about the population of entries. Watch the same entry pass the first gate and get flagged at the second. And notice what that does to the framing: neither placement is a superset of the other, so the interesting question is not which one to choose. It is what to put at each. In a design review they are 2 line items, and most systems have budgeted for 1. So what does each one miss? Write time is blind to anything whose meaning depends on a context that has not arrived, and to anything only harmful in combination with an entry written later. It is blind by construction rather than by weakness, which is worth repeating because it means improving the inspector does not help. Read time is blind to anything already acted on before the first retrieval, and it has no population view. It sees this entry, not the pattern across the store. And it costs more. Reads outnumber writes in every agent in this series, so a read time check has to be cheap enough to run at read volume. That constraint shapes the whole second half of this episode. The defense literature starts from 2 properties of the threat, and they are worth stating precisely. First, context-dependent harm. A record can read as a perfectly reasonable general preference and be harmful only when a specific situation arrives. Audited on its own there is nothing to object to. Second, a self-reinforcing error cycle. The corrupted outcome gets stored as precedent, which amplifies the original error and progressively lowers the threshold for similar attacks afterwards. And there is a measurement. Even advanced model-based detectors miss 66% of poisoned entries when auditing them one at a time. Both are about an entry's surroundings rather than the entry, which is why per-entry auditing loses. The first mechanism is consensus, and the word needs care because it is not the consensus we criticized in episode 9. For each query, retrieve several related memories and let each one generate its own reasoning path. A poisoned entry produces a path that diverges from the paths the benign entries produce, and the deviation is what gets flagged rather than the content. So the unit of comparison is the reasoning a memory induces, not the memory itself, which is what turns a read-time check into one with a population view. The framework's own summary, memory itself must become both self-checking and self-correcting. Comparing models and comparing memories get sold under the same word, and they are not the same thing. Which lets me place it on episode 9's axis honestly. Episode 9 said the strength of a verifier is how little it shares with the thing it checks, and it put cross-model consensus in the cheap and weak cell because several models share a training distribution, so their errors correlate with the errors they are meant to catch. This consensus shares the model too. But the things being compared were written at different times, by different interactions, and were not chosen by whoever wrote the poison one. And the separation has measured support. The relational structures of benign and malicious reasoning paths overlap by under 1%. The axis outlives any particular design, which is why it is worth more than the mechanism. The second mechanism is a second store. When a path is flagged, the flawed path itself is distilled into a lesson and archived separately, so there are two stores rather than one, the primary memory, and a dedicated repository of negative lessons. Before acting, the agent checks its proposed plan against that repository, and a structurally similar past failure triggers a revision. Which means a detected failure is not discarded. It is kept, in a place where it can only ever be consulted as a warning. And that is precisely the mechanism the previous episode's threat model needed. It is also a store somebody has to maintain, and too many lessons start to hurt. And it is measured, across 4 settings: direct poisoning on a knowledge agent and a healthcare agent, indirect injection on a general agent, and misinformation in a multi-agent system. 2 backbones, 2 retrieval architectures, 4 baselines. Attack success cut by over 95% overall and over 97% in the healthcare scenario. Indirect attacks down by more than 60%. In the multi-agent setting, the highest task success rate at 0.95. And the number I would take to a budget meeting, 7.8 thousand tokens against 8,000 for the auditor baseline it outperforms. Effectiveness and cost in one table is rarer than it should be. And here is what I think is the most useful thing in this episode. That second store is quarantine, with a use. A quarantined item is not deleted and not hidden, it is an item that can only be consulted in one direction. Episode 9's pipeline rejected candidates and discarded them. This design rejects and keeps, in a separate store with a single permitted reading. Which turns quarantine from a holding pen into a defensive asset. And it answers a question episode 8 raised about what a rejected candidate is for. Episode 8 kept worse variants as stepping stones, and this keeps worse variants as warnings. Rejecting and keeping is a different engineering commitment from rejecting and discarding, and the difference shows up in the schema rather than in the algorithm. A second design, from the paper that measured the attack in episode 10. A memory saving policy at write time, and a retrieval screen at read time, the same 2 placements as slide 4, filled by one system, which is exactly the composition this episode is arguing for. Its reported effect is that it dramatically reduces the attack success rate while preserving agent utility, and I am quoting the paper's wording rather than inventing a percentage it does not state. What I find more persuasive than either result is that two independent groups arrived at read-time screening from opposite directions, one from the detection argument, one from the attack measurement. Convergent design from two directions is stronger evidence than either result alone. For mechanisms, and the useful way to lay them out is by where each can sit and what each is worth. Detection flags an item or a path as anomalous. It is the cheapest and the only one of the four that can be wrong in both directions. Cross-checking compares against an independent source and is exactly as strong as that source's independence. Consensus compares an item against its peers and needs those peers to be uncorrelated. And isolation keeps the item out of the decision. Read that last one carefully, because it is the mechanism that survives a wrong verdict. It does not need to be right. It is also the only one a non-specialist can verify by reading the code. Which brings the data model, and I want to be explicit that this schema is ours. 5 fields per item, source, specifically enough to go back and recheck. Channel, which of the 4 right channels admitted it. Trust level, as a value a query can filter on. The verifier verdict, which check passed it and at which stage. And the validity interval. The distinction in the title is the whole point. A log records what happened, a data model lets a query decide. The difference is whether trust is a field you can filter on, or a story you reconstruct afterwards when somebody asks. Make trust a stored field and everything downstream becomes a query instead of an argument. And 2 of those 5 are new, which is worth pausing on. Episode 5 already asked for source, the 4 clocks, derivation, and the writer's identity, and the 4 clocks are where the validity interval comes from. Episode 10's threat model added 2 more. Channel, because the channel is what determines right authority, so an item with no recorded channel cannot be assessed at all. And trust level, because a verdict has to be a value rather than a note. The record did not grow because somebody wanted more fields. It grew twice, and each time a later argument required it. Fields an argument demanded tend to survive, fields somebody wanted tend to go unpopulated. Trust is not a scalar, and treating it as one is the commonest mistake in this area. It is a partial order over channel, source and verdict. Trusted, an authenticated source, through a channel with a named right authority, with all 4 obligations discharged. Provisional, one obligation unmet, or an inferred right channel with no inspector. Untrusted, an obligation contradicted, or an unauthenticated source on a high authority channel. And here is what a scalar hides. An authenticated source through an uninspected channel, and an anonymous source through an inspected one, are not ordered. Forcing them onto one number picks an answer silently. One warning before the mechanisms. When provenance is retrofitted onto an existing store, every existing item has no channel and no verdict, so each one is either untrusted by default or trusted by default. Untrusted by default means your store effectively empties on the day you deploy the gate, and somebody switches it off that week. Trusted by default means the retrofit is decorative, because the items most likely to be poisoned are exactly the ones that predate the record. There is a third option, migrate channel and verdict from the write log, for items where a write log exists. Which is an argument for keeping one now. Leaving out the unaccessible state is what forces the false choice above. And the trust level comes from the 4 questions this series has been asking since episode 1. Correct, grounded in an execution or a named source, and unmet drops it to provisional. Consistent, no contradiction with what the store already holds, and contradicted drops it to untrusted, because a contradiction is evidence, where a gap is only an absence. Current, a validity interval is set, and expired drops it to provisional rather than untrusted, because it was true once. Complete, the required fields present, including channel, and a missing channel means the item cannot be assessed at all. Note that a contradiction and a gap are treated differently throughout, because one is evidence and the other is only an absence of it. So one distinction that decides how all of this is implemented. Filtering decides what you can see. Gating decides what a decision may rest on. A filter that hides a suspect item also hides the evidence that it was suspect, so the next person to investigate has nothing to look at, which is how a defense destroys its own audit trail. A gate leaves the item retrievable, visible and attributable, and stops it influencing one specific class of action. And that is why the second store works the way it does. It is a gate on the primary store's authority, not a filter on its contents. A defense that destroys its own audit trail also destroys the record you would improve it with. Which requires defining high stakes, and it is usually left as a gesture. 3 tests. Is it irreversible? Because if you cannot undo it, the rollback path does not cover you and the gate is the only protection you have. Does it cross the boundary? Does it move money, data, or an instruction outside the system you control? And would you want a human to have seen it? Note the phrasing on that third one, not would a human approve, but would you want the record to show that one had looked? Any one of the 3 is enough, and the third catches actions the other 2 miss. None of the 3 asks you to estimate a probability, which is deliberate. So here is the grid this episode exists to produce. Episode 9's 7 rungs down the side, Episode 10's 5 lifecycle stages across the top, and a mark where a rung can actually sit. Schema checks work at write and persist and nowhere else. Solvers and test oracles only make sense at the point of action. Execution replay covers retrieve and act. Cross-model consistency only retrieve. And now look at the read-a-still column. It has exactly 1 entry, and it is human spot audit, the most expensive rung on the ladder. Episode 10 called Redistillation, the stage nobody inspects. This is why. 3 requirements, and the honest thing to do is give each its own cost. Every write reversible, which means the store keeps the prior state, so storage grows with corrections rather than staying flat. That is episode 5's version facts doing security work. Every rollback logged, because a reverted item has to leave a record that it was reverted. Without that, a rollback is just a deletion performed by somebody with permissions. And every retrieval attributable, which is the expensive one, because it scales with reads, and reads are the high-volume side of every system in this series. Storage growing with corrections is simply the price of being able to answer questions about the past. And here is the whole thing assembled. For channels in, 1 action gate out, for inspection points between them, and each point carrying the rungs that can sit there. The trust level travels with the item, so the action gate does not have to rederive it, which is the practical reason trust has to be a stored field rather than a computation. Watch the read-a-still path as it appears at the end. It is the only route from the store back into the store, it is the route that launders provenance, and it is the one with a single available inspector. If you build one thing from this episode, put something on that path. Everything else there has at least 2 available inspectors. Which reduces to 4 questions per channel, in 4 categories. Admission, who can write, is it authenticated, what inspects it? Attribution, can you name the source, the channel and the writer for any item in the store? Authority, Which actions can this trust level influence, and who set that mapping, because if nobody set it, it is whatever the code happens to do. And reversal, can you undo it, is the undo logged, and can somebody other than the agent perform it? 12 questions, 3 per category, and the full list is in the repository rather than on this slide. A checklist nobody reads is indistinguishable from one nobody wrote. Lab 11. Add the 5 provenance fields to your store, backfilling channel and verdict from the right log where you have one, and marking the rest unaccessible rather than trusted. That distinction is the whole migration. Then pick exactly one high-stakes action by the 3 tests and gate it on trust level. Run it in shadow mode for a week, count what the gate would have blocked, and read 10 of those to decide in each case whether the gate or the item was wrong. One action rather than all of them, because a gate that blocks something important in week 1 is removed in week 2. The count you come back with is the argument you will need in order to widen it later. 5 takeaways. Neither placement is a superset of the other. Write time is blind by construction to context-dependent harm, and read time is blind to what was already acted on and costs you read volume. Consensus across memories is not consensus across models, and the measured support is a structural overlap under 1% quarantine with a use, or rejected item kept in a separate store, consultable only as a warning, is what breaks the self-reinforcing cycle. Provenance is a data model rather than a log, and a retrofit needs a migration rather than a default. And 7 rungs against 5 stages, where the redistillation column has one entry and it is the dearest rung there is.